Resit Factors taper, question number 3. This one's solving a differential equation. I notice differential equation because it's got a differential in it and it's got some sort of equals in there. In these particular type, quite straightforward. All I have to do is get dy dx on its own, and then I can solve it by integrating both sides. So let's rewrite the differential equation. So adding 5x squared to both sides, I get 10 times dy dx, the differential, 5x squared, dividing both sides by 10, I get that the differential is 5 over 10 is a half x. So now I'm going to integrate both sides. If I integrate the differential, I actually undo the differential, so I'm left with just y, but then I also integrate this side. So y equals the integral of a half x squared. And how do I integrate? Look at the table of integrals, but what I do with these ones is just add 1 to the power and divide by the new power. So the power is 2. So adding 1 to that gives me x cubed. So it's a half times x cubed over 3 plus c. 3 times 2 gives 6, so this gives me 1 over 6, or 6 of x cubed plus c, which is the answer that you're actually asked to come up with in part A. Part B, find the particular solution given that y equals 5 and x equals 2. So that means that given this general solution here, so this is the general solution, and it's the general solution because I don't know c, by putting the values in for the particular solution for part B, I can find out what c is and then come up with this particular solution. So what I have to put is it, I know that y equals 5 when x equals 2. So I just put these values into my general equation. Y is 5, x is 2, and that will allow me to calculate c. So 5 equals 1/6 of 2 cubed plus c. So timesing both sides by 6 to get rid of the 6, 5 6 is 30, 2 cubed plus c. 2 cubed is 8, so 30 equals 8 plus c. So subtracting 8 from both sides, I get c equals 22. So my particular solution is y equals 1/6 of x cubed, in other words the original formula, but now I know what c is, 22. So that's the particular solution. Okay, that's that one done.